Thank you for joining our webinar on the benefits of using cannulated versus solid raw material. Our speakers today are Thomas Gagan, General Manager of Forecreu America, and Dale Tempko, an orthopedic industry consultant. Forecreu designs and manufactures hollow round bars with various types of steel and titanium from an extruded drawn process for use in surgical tools and implants. Approved by all major OEMs in the industry, Forecreu has become a reference in the orthopedic, trauma, and sports medicine spaces.
Hi, everyone. So in this presentation, we will be talking about using cannulated versus solid raw material. We're talking from Forecreu America. Forecreu America is the US subsidiary of Forecreu France, where our company is headquartered and where our material is produced. So a quick background on Forecreu. Forecreu is a family-owned business that started in the early 50s by Jacques Horry. It is still now run by his son, Francois Horry. Our original founder spent about 25 years developing an extrusion drawing twisting process from what originally was the coolant-fed cutting tool industry, our historical industry. In 1986, we started developing cannulated stainless steel material for medical applications. Those were our first steps in the medical industry. A few years later, we introduced cannulated titanium, further digging into the medical world. Growth and expansion over the next few years, we opened our US subsidiary in 1999 in Chicago. Second plant was opened near the first one. Extrusion press was brought in-house, or extrusion is done in-house. And more recently, we added a Cox rolling mill that is drastically increasing our production capacity. So while tooling is our historical industry, medical has been our main growth driver the past few years to make up about 66% of our overall sales today. It's become increasingly apparent during COVID. We've seen the auto and aerospace industry trending down. The medical industry has proved to be a very resilient market, and we're happy to see that our customers' business did not slow down during the crisis. So, in fact, Forecreu America posted a growth of 15% in 2020, making up almost 50% of our overall sales. We have in the US a very strong customer base, about 140 plus active customers, a solid business model with a large inventory of common grades and common sizes available to ship on our shelves in Chicago, and of course a very robust US market as a decision-making center driving the industry globally. Our manufacturing steps in order to get to a cannulated bar, we start with cutting bars of about roughly 4 to 5 inches in diameter. Cut them into billets, drill a hole in the billets, and then insert a mandrel. At this point, we have a billet that is ready to be sent to extrusion. So the billets are heated up in induction heating ovens up to forging temperatures, and they are then extruded down to roughly 3/4 of an inch. So at this point, we have a cannulated bar with a wire inside. The grade and the size, the final size, will be the main factors determining the next processing route. But our material will either go to drawing benches where we do hot or cold drawing, or to our rolling mill. So it starts a lengthy process to progressively reduce the diameter of our material with heat treatment as intermediate steps. Final steps, we have to remove the wire that's inside the bar. So we will pull on both ends wire will break, and then we will be able to remove the entire wire. It goes through straightening, centerless grinding, precision grinding, and final controls before packing and shipping and being sent here behind me. So then at last we have material on our shelves and ready to ship here from Chicago. We're not limited to the applications on this slide, but the bulk of our material is used for either instruments or implants. So when it comes to instruments, we will see it being used for drills, taps, reamers, drivers, and when it comes to implants, spinal, pedicle, and trauma screws, but also IM nails. So Dale, you have years of experience at Medtronic, more recently as an advisor and consultant. What are your thoughts on using cannulated bar?
Well, generally, there's a belief that cannulated bar is expensive. And at first glance, it is. The cost of solid bar is a lot less than the cost of cannulated bar. But you need to look at the whole picture. For years in my roles, I've seen attempts to do cost reductions by changing from solid bar to cannulated bar. And often these savings were there, maybe not as significant as what people would like to see to make so they didn't make the change. Sometimes they did, sometimes they didn't. But I saw a problem with what people were doing.
A problem?
Well, people would only compare the cost of the cannulated bar to the cost of drilling the hole.
Okay, and what's wrong with this approach?
To explain this, it's best to look at an example. And before we look at an example, let's look at how there are different approaches to making cannulated instruments and implants. So if the device is kind of long, too long to drill in a machine, which is usually a Swiss, then people have two options. They either use cannulated material, cannulated bar stock, or they send the part out for gun drilling, or they do gun drilling in-house. In either of those cases, they have a second operation to only do the gun drilling because it's too long to do in the machine. If the length is shorter, around 4 inches or so, many people have chosen to drill in their Swiss machines.
Yeah, I've visited a lot of contract manufacturers, and they work gun drilling in their Swiss machines.
Yeah, it's become quite common, especially lots of companies have invested in high frequency drilling, like the Tribomam. And these systems are somewhat expensive. And I've gotten feedback that, they haven't really panned out to some of the expectations people had. They tout them as having huge increases in feed rates. And a lot of times that didn't materialize. So I think a lot of people that made these investments might have chosen to go with cannulated bar if they would have looked at the options and the analysis a little different.
What do you mean?
So like I said earlier, people would only compare the cost of cannulated bar to the cost of drilling. And the cost of cannulated bar is easy, right? You get a hold of Forecreu and ask for a quote. And the cost of drilling is pretty easy too. You look at the drill time, and then you multiply it times the fully burdened chop rate.
Right. That seems like a reasonable approach.
Yeah, so far it's okay. But a lot of people stop right there and they didn't get the whole picture. So one thing they miss is the cost of the drills. And many people, especially big OEMs, treat consumable tooling as an expense. So it doesn't really go on the cost of the part, it rolls up into an expense. And that makes sense for things like inserts and lower cost products. But when you get to these expensive drills, it kind of masks where the costs are really going. And so that's kind of an issue, and people wouldn't consider the cost of the drills. The other thing is there are also indirect costs too that have kind of come out. And one of these is, shops pushing feed rates, and so when they're pushing the feed rates, they have a higher chance that they're going to break the drill. And some of the guys have said, hey, this is disastrous. If I break a drill on an off shift or a weekend shift and the operator can't get the machine going, that machine could be going down for a shift or two or even more. And in some cases, the guy told me, he says, hey, I lost the whole profit on that job because I broke a drill and the machine went down.
So we have customers who are now using our bars for exactly this issue. So what is, in your opinion, the right way to evaluate using cannulated bar?
So let's take a look at an example. Here we have a cannulated driver, right? It's 17.4, 4 inches long, 171 OD, 049 ID. It's got a AO quick connect at one end and a T8 Torx on the other end. So let's see how these stack up side by side. So in this case, the length is about 4¼ inch after you allow for parting and for bar drop. So at $1 per foot for solid bar and $32 per foot for cannulated bar, we get a cost of 38 cents and 11.75. And then we need to look at cost of drilling a hole. In this case, the feed rate was about, I think, 0.67, and which put us right about 6 minutes for drilling. So and the shop rate in this case study was around $70, so we were just shy of $7. We are going to look at the cost of the drills here. So in this case, they were changing the drill every 17 parts, and the drills were pushing $100 each. So that added about $5.88 a part. So in this case study, when you stack them up side by side, we had a cost reduction of about $1.50. And in this case, there were a few hundred, around 300 of these parts a month. So yeah, it could save a few, thousands of dollars a year. But this is where a lot of people make the mistake of stopping. Okay, they stop right here and say, yeah, I'm going to go ahead and go forward, or no, it doesn't look that good. And one of the biggest things they miss is not understanding the change in productivity, the increase in productivity that comes with using cannulated raw material.
Right. So some of our customers have mentioned that they've seen increased production rates. So how does this happen?
So the easiest way to take a look at this is to look at the production rate in parts per hour. So this driver, when it was made from solid bar, had 14 minutes in the main and 3 minutes in the sub. So we're getting a part every 14 minutes. That's about 4.3 parts per hour. When using cannulated material, the time in the spindle dropped to 8 minutes. So because we took the 6 minutes of drilling out, right? So now we're getting a part every 8 minutes, which is 7.5 parts per hour.
Yeah, which sounds like a big increase.
Yeah, we went from, in this particular case, from 30 parts a shift to 52 parts a shift. So at 300 parts per month, now it only takes 6 shifts to do what we were doing in 10 shifts. So, there's some really opportunities for some big increases here. And this part was a little bit on the long side. So the drilling time compared to what the other work was being done in the main gave us that advantage. But even with shorter parts like bone screws, we still can see significant increases in production rates.
So how difficult is it to find these opportunities?
So when you're drilling in your Swiss, it's actually quite easy. There's a ratio, and the ratio is basically the drilling time in the main, and then you divide it by the drilling time minus, or the total time minus the drilling time. And as long as you're not, as long as your sub time isn't greater than that, this is a good indicator of the kind of production rates you'll see. So let's take a look at one more example here. So here we have a cannulated compression screw. It's tie 6.4. Again, it's about 4 inches long, or it's 100 millimeters, and it's got a T15 Torx. So in this example, the time in the main was 12 minutes, and there was about 5 minutes of drilling time. The feed rate was about 0.8 inches per minute. So this produced a ratio of 0.71. So in this case, we went from 5 parts per hour to 8.6 parts per hour. This is a 76% increase. So again, anytime that you have a lot of drilling time compared to the rest of the work in the main, it can be really a significant increase in production rates.
Yeah, 76% is a big increase. So what if the parts are shorter?
So in this particular case, on the case study, this was part of a family. And so we grabbed a screw that was a 45 millimeter long screw. And in this case, the ratio was 0.4. And even at 0.4, we went from 6.5 parts per hour to 8.8 parts per hour. So this is still a decent increase, 35%. So if you're looking at cost reduction, you say, what can I do to reduce my cost? Even the shorter screws have a real significant advantage. So anybody that's drilling in their Swiss machines should be looking at cannulated bar. They can add capacity without having to build building, expand their facility, buy more machines, train more operators, add shifts, all these things. This capacity comes just by changing it to cannulated. The contract manufacturers will get this. It might be tough for OEMs because of some challenges when the bigger OEMs look at standard cost. So standard cost is also referred to as LBM. That's labor, burden, and material. And in this particular case, what we did is we shifted the labor and burden and offset it in the material. So the material is more expensive, but the labor and burden went down. And so this results in the productivity or the added capacity that we can see. But it doesn't really significantly change the standard cost. So let's look at an example where there's a shop running, say, they have 4 Swiss machines dedicated to running cannulated bone screws. So if they're running 3 weekday shifts and 2 weekend shifts, that's about 2,900 shifts per year. And a shop can make about $300 to $600 per shift off a Swiss. That's profit. So if you had an increase of 40%, we just saw 40% is probably pretty easy if you have a range of screws, and especially some that are longer. That would add 1,150 shifts of additional capacity a year. Yeah, that's right. Over 1,000 shifts of capacity. So when you're talking about $300 to $600 in profit per shift, that could turn into, off these 4 machines, increased profitability of $350,000 to $700,000. So it's very significant. But the key here is you have to use the capacity. And this is where the finance people often kind of get hung up a little bit and say, well, you didn't reduce my standard cost. And if you don't use it, well, everybody's busy, and you can reduce off shifts and do all these things to better utilize your equipment.
So what about shops that are not gun drilling in their Swiss machines?
So there's benefits for them too. It's a little bit more difficult to quantify what those benefits are in dollars. But if a shop is sending parts out for gun drilling, that can be expensive, right? So you're adding cost. Even if you're gun drilling in-house, you have additional cost, right? If you gun drill outside your Swiss, a lot of times the parts have to be straightened afterwards, and then you have to bring them back in. A lot of times there's more operations that you need to do to complete the part. So the logistics, the lead time of chaining all these operations together makes your lead time longer. And then, it consumes a lot of resources. You got, people that, operators, setup guys that got to set up multiple machines. They got to bring it back in, set up again. And, if you're doing that, then you have setup parts that you're wasting. So again, if the runs are relatively small and you waste a few pieces in setup, it all adds up. And there's also a benefit of being able to drop the part complete off the Swiss. Your quality is predictable, your lead times are predictable, and you're not at the mercy of the gun drillers, if you're outsourcing, of the gun drillers backlog.
Okay, Dale, thank you so much for the presentation and to help us understand the benefits of using cannulated material. So we understand that OEMs, contract manufacturers are constantly being pressured for cost reduction for new products, but also for existing lines. So the point to show here is to show that using cannulated material represents an area of opportunity for cost reduction. So we have stock here in Chicago. If you need help in reviewing your current production or new production, we can look at your data. We can look at the parts that you're running and look at where opportunities for cost reductions are. And that is it for me.
Thank you to Thomas and Dale, and thank you to those watching. You can learn more about Forecreu at forecreu.com or connect with them by using the link on the webinar session page. To access more from OMTEC's virtual education series, visit omtechexpo.com.